All right, for this lesson, we're going to be talking about rotations. There are two different types of rotations, and if you think about a clock, we talk about the hands of a clock rotate clockwise, and then we talk about counterclockwise, which is the opposite of a clock. Now, one thing that you need to make sure before we get into more details is you need to understand that there are 360 degrees, and the little degree symbol is like a little exponent circle and a circle. Now, when we rotate clockwise or counterclockwise, if I have clockwise or counterclockwise, no matter what position I'm in, those two should always add up to be 360 degrees. Okay, so if we think about clockwise, now normally we would think about, okay, 12 is up here, then we have 3, 6, and 9, and we rotate this way with a clock. Now, we're still going to do this type of rotation for clockwise. However, in a unit circle, which you'll get to later on down the road, when we talk about rotations, this is normally 0 degrees. This is normally 90. This is normally 180. This is normally 270. And then we come all the way back around to 360. So, again, a lot of that depends on some of the things that we're doing. However, the position of these things are somewhat important. So again, this would be counterclockwise. So if we're thinking about 12 being here and then 3, 6, 9, we're going the opposite the direction of a clock. Keep in mind though, this is still going to be 0 and 360. This one is 270 and I'll go in. So this is 90. This is 180. 270 and 360. So really, when we talk about a rotation, and you'll learn this when you get to the unit circle, a rotation actually goes counterclockwise because it starts in that positive x-axis where all of my values are positive there, and then it starts there and rotates in a counterclockwise counterclockwise position. Now, I want to kind of show you what I mean by a rotation. So if I come here to this little activity that I found, you see that there's a point. Let's think about the point as being the origin. So we have this original shape here. So if we want to rotate it, and if you see it's rotating in a counterclockwise position here. All right, so if you see that, we're going counterclockwise. Okay, so that rotation around that point until we get all the way back to it, and it can be at the same position at 360. Okay. Now, if I go the opposite way, so like if I go back to 0, all right, so I'm trying to get this as best as I can. Go back to 0, and I go the opposite direction. So I'm going to go clockwise. Now, if you notice clockwise here, it's going in a clockwise position. So this says negative 65 degrees. But over here on this side with the angle that's on the left, you can see that it's actually showing you that same rotation in the clockwise position, that if we added those up, it would equal 360. So if we're going clockwise, we're rotating the opposite direction, and we can always wind up. So it may say rotate it counterclockwise by 90 degrees. So if I rotate it counterclockwise by 90 degrees, it's kind of like rotating in it one quadrant. So that's rotating it counterclockwise by 90 degrees. If I go clockwise, we're going to go and we're going to make that a negative because we want it to rotate the other direction. And that's going down and rotating it basically a quadrant in 90 degrees. So 180 is technically a half a circle, a straight line. So 180 degrees is going to put it in the opposite, basically almost like a reflection, but it's not a reflection because it's being rotated. So if I do the same thing here, it's actually going to put it at that same spot. So if we rotate it 270, that's going to be 3 quadrants. If we go the opposite way of 270, that's going to be 3 quadrants in the opposite direction. Okay, so rotations are just a little bit different. So just to kind of clarify, so we want to rotate P, and we want to rotate P to P prime. So what they're saying is we want to rotate P here, and that P that we have. So we want to rotate this, and we want to rotate it to P prime. So what do we have here? Well, that first rotation, if we're rotating it from P to P prime, the way that I did it in purple, that's going to be in the clockwise. So if we're going clockwise, that's going to be 75 degrees. How do I know? Because it shows 75 degrees inside that angle. Now, if we want to rotate it counterclockwise, so if I'm starting with P here and I rotate it all the way around, okay, that's putting me at a different rotation counterclockwise. So remember, the whole total is 360, but we got to subtract the 75 that was clockwise, and that's going to leave me at 285. So we're going counterclockwise by 285 degrees. So technically we would have landed in the same position. It's just about how we rotated it and in what direction. So again, if we add these two up, these should always equal 360. So again, that would be 10, and then that's going to be 8 and 8 is 6. So that's going to be 360 degrees. All right, so again, if I focus on my rotation here, so we're starting with P. So we have P here, and we want to rotate to P prime, okay? So we got a couple of directions that we can go. So we could head, and we could go in the clockwise direction, and that's going to be a straight line there. So that's 180 degrees. So we rotated clockwise 180 degrees. But we could also rotate counterclockwise and go the opposite direction, and that's going to put me at the same position, which is also 180 degrees, just rotated in a different direction. But again, when we add those two up, it's going to equal 360 degrees. Okay? All right, and for this one, we have P, and we want to get to P prime. So there's a couple of ways that we could get to that. So we could start out by saying, okay, P to P prime, we're going to rotate counterclockwise, and that counterclockwise is going to include that 140 right there. So counterclockwise is going in the opposite of a clock, so that's going to be 40 degrees. But if we go clockwise, and remember clockwise is in the position of a clock, we're going to rotate the clockwise, just like a clock would in the clockwise position, and that's going to be 360 minus the 40 that we didn't have to rotate all the way around, and that's going to leave me at 320 degrees rotation clockwise. So just keep in mind that rule is going to be helpful for you later, especially when we're talking about rotations, and then we start talking about angles. Like, all of these things are going to start kind of flowing together, especially into our next unit. Okay, so if we look at this figure, they want to know which one of these figures is a rotation. Okay, so if we're talking about a rotation of the original, so here's my original. All right, so if we rotate it, remember, if we rotate, that means that the head's going to have to kind of either go one way or the other. So it's going to, so this one is a reflection, okay? So if you notice this one, the head is still in the same position. It's just showing in an opposite direction, so that's a reflection. All right, so I have cropped the image here so you can kind of see the rotation. So we're going to kind of look at it in clockwise or counterclockwise. All right, so I'm going to start by rotating it in a clockwise position. So if I'm rotating it here, so this is the first one that that looks like a rotation to me. So does it match that one? So if it rotates, you see that the legs and the head and the body are actually not in the same orientation if we rotate it all the way. So when I look at this image, so obviously that one looks more like a reflection to me. So I'm going to do it in the opposite direction and do it counterclockwise. So if I do it counterclockwise, Still doesn't matter. Still going to give me that reflection image of that one. So that looks like, honestly, that's probably showing more of a combination of transformations here. So when I'm looking at which one is a rotation, the rotation is obviously, in this particular situation, it's going to be B. So we've got to look at what are the, where the head, where's the legs, how is it rotating, okay? So again, they want to know which one of these is a rotation. So this is my original. They gave me a car. So in order to be a rotation, remember, we've got to think about how it's going to rotate. So I'm just going to go ahead and make an image of this and use this in our problem so we can clearly see the rotation here. So we look at this one, this is the same exact image. Well, if we rotate it, will it come back to the original position? So I'm going to rotate it a full 360 degrees and come back. Well, that looks like it rotated to me right back to the same position here. Okay, so if I rotate it the opposite way, so rotate it and it comes back. So that could be, or A is a rotation, it's just a full 360 degrees. So if I rotate this one, no matter which direction I rotate it, the head and the wheels and obviously the car are all facing in the opposite direction. Okay, so looking at this one, that one does look like a rotation. So this one actually has 2 rotation answers in it. So it says which figure is a rotation of the original, but the A and C are both a rotation. Because again, if I rotate this one, it's going to rotate. All right, so if I kind of measure what I'm doing here, this is going to be like 90 degrees. This would be 180 degrees. That would be 270. And if we come back around, it's going to wind up at 360. Again, we already saw the other one didn't, but I can rotate it 90 degrees, and it does, in fact, match A and C. So I would say A and C are both rotations. So this one actually, I feel like, has 2 rotations. So this one looks like it's rotated a full 360 degrees. And then we saw that this one was rotated about 90 degrees. And the other one, when it did the rotation, it didn't actually face the correct direction. All right, so we do have some rules here that we can use to help us do these rotations. So some of these go together because they would be in the same position. So remember, 90 degrees clockwise is 270 counterclockwise, because we had talked about that earlier, that they should always add up to be 360. Okay, so if we do 90 degrees clockwise or 270 counterclockwise, the rule here is that if we have an X and a Y, we flip the X and the Y, but then the X value, we're going to change the sign. If I rotate 180 clockwise or counterclockwise, you just inverse the X and the Y. And then 90 degrees counterclockwise and 270 clockwise, you do the exact opposite. You're going to flip the X and the Y, but then the Y is inversed. Okay, so these are really important rules that you've got to know. So we want to rotate, in this particular problem, we want to rotate the triangle TRY. We want to rotate it 90 degrees clockwise. Okay, so if we're doing 90 degrees clockwise, that means that 90 degree clockwise is going to be our rule here. So that means that we're going to be rotating this, and our values are going to go Y, negative X. So we're going to write down our points for the original. So the T is located at -7, +1. Our R is located at -8 and 8. And then our Y is located at -3 and +5. So if we apply that ruling for the prime, we're going to flip the X and the Y. but the original x is going to change sign. So remember, this is your x and this is your y. So when we flip this, the 1 is going to go in the x spot, and the -7 is going to go on the y spot, but we're going to change signs. So that's going to become +7. All right, so just like the r, the x is going to become a +8, and then the y is just going to stay +8, okay? So remember, this is becoming y and -x. So y negative x. And then we have -3 and 5, so the y is going to go to and become, or going to stay 5, but we're going to put in the x spot. And then that +3 is going to become, or excuse me, that -3 is going to become +3. So if we plot this, so I'm going to go to 1 and 7. So that's going to be my t prime. Then we have +8 and +8. That's going to become my r prime. And then we have +5, +3. So that's going to become my y prime. So if we connect all of those, you can see that rotation there. So I know it's kind of hard to visualize. Again, I can try to help visualize this a little bit. Show you, I'm gonna have to kind of work backwards on this just because of the fact that the original is part of the notes, but I can copy my own handwriting here. So if I rotate, so originally we rotated it 90 degrees clockwise. So I'm going to rotate it back the opposite direction of counterclockwise by 90 degrees. And if you notice, that lands right on top of it. So the only difference is that it's rotating. As I'm rotating, I'm kind of going like this around the origin. So it's kind of hard for me to completely show it, but then it lands here. Okay? All right, so this one we want to go counterclockwise. So now we're going 90 degrees counterclockwise. So if we want to go counterclockwise, we're going to basically be doing the opposite. So we're still going to flip that y and the x, but this time because we're going counterclockwise, that y is going to be the one that inverses and the x is going to stay the same. So again, let me reference that. The 90 degrees right here is the same thing as 270 clockwise. So the y is going to inverse and the x is going to stay the same. All right, so let's write our originals here. So the t is located at +3, -9. The r is located at 2, -2. And the y is located at 7, -5. All right, so if we're looking at that, we're going to take these values. That's my x, that's my y. And the x and the y are going to flip, but the y is going to inverse. Okay, so we're going to take that y value. So the first one, the t has a -9, so that's going to become a +9, and the x stays the same. So for r, my y is a -2. We're going to inverse that to make it +2. And then my x is going to stay +2. And then for the y, for the y, the y value of the y is -5. So that's going to become +5. And we're going to switch that x. So if I were to plot these, this is going to be +9, 3. So that's going to be my t prime. Then we have r is 2, 2. Okay, so that's going to be r prime. And then finally we have 5 and 7. So that's going to be my shape. So once I connect these all together, you should see my rotation here. And again, I can copy this, and that is not... So this should actually be Y. All right. So once I go to copy this, I can show the rotation here. All right, so again, I'm going to rotate it. So it said that it was rotated by 90 degrees. So, and that's counterclockwise. So if I go counterclockwise, I would be rotating it this way by 90 degrees. Okay, however, that's going to be my original. So what I'm going to do is I'm going to put this one back where it originally started. Okay, and it's not perfect, but it should work. And we're going to be rotating it 90 degrees, and we're going to rotate it 90 degrees counterclockwise. So we're going to rotate it in the opposite direction 90 degrees. So obviously it would have rotated around the origin and landed right where we had it. All right, so then we have 180. So if we're doing 180, and 180 is essentially a straight line, so it's not going to matter whether we technically are rotating it counterclockwise or clockwise, because it's going to give me the same values. So my t in this one is at -2 and -9. So my r is located at -3, -2. And my y is located at 2 and -5. All right, so the rule for 180 degrees, whether it's counterclockwise or clockwise, is going to be -x, -y. Because basically, when we go 180 degrees, all the points are going to go in the completely opposite direction. So if we do this, that's going to become +2, 9. This is going to become +3, +2. And then this is going to become -2, +5. All right, so if I plot these points, I should be able to see that rotation. So this is going to be 2, 9. So that's going to be t prime. So I have 3, 2, which is going to be r prime. And then I have -2, +5, which is y prime. All right, so if I connect all of those, there is my rotation. So again, if I kind of want to visualize this, I'm going to make a copy of that. I'm going to rotate it to fit back to the original, just like it was previously. And again, it's not going to be perfect, but pretty close. So there's my original. All right, so if I rotate this, okay, so remember I'm rotating it 180 degrees and we're going clockwise. So clockwise is going to be in the regular position of a clock. So we're going to be rotating it around the origin, and we're going to be rotating it to be 180 degrees, and it lands it right where it should be. Okay. We're going to do a collaboration of rotations and reflections and some translations. So we're going to do them a little bit at the time. So for number 4, we're going to do a rotation of 270. We're going to do a reflection over the line over the line x equals 1, and then we're going to translate it, and we're going to get our final answer as bug. So we're going to rotate 270 degrees clockwise and call it hat prime. So first thing I'm going to do is I'm going to identify my values. So my h is located at 2, -2. My a is located at 7, -6. And my t is located at 5 and -9. All right, so if we're going 270 degrees clockwise, so remember our rules up here, so 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So we're going to flip the x and the y, and then we're going to inverse the y. All right, so our rule here is that we are going to flip the x and y, and then we're going to inverse the sign of y. So this is for hat prime, for our rotation. This is going to become negative. We have -2 as the y, so that's going to become +2, and the x2 is going to stay the same. My y is going to change to a +6, and my x is going to stay the same. And then my y is going to become +9, and my x is going to stay the same. So we're going to plot these first, and I'm going to highlight and kind of color code as we go for these, just so that you can keep in mind what the steps were. So this is 2, 2. And this is H prime. All right, then we have positive 6, positive 7. So that is going to be A prime. And then we have positive 9 and positive 5. And that's going to be T prime. So if we connect these dots here, that is my rotation of 270 degrees. So really, again, it looks like a rotation. So if we're rotating it here and around the origin, we would have been rotating it counterclockwise clockwise 270, or it could have been counterclockwise by 90. So that's the reason they're technically the same. So now we're going to do a reflection, and we're going to do a reflection this time over the line y equals x equals 1. So I'm going to come over here. I'm going to plot my line for x equals 1. And we're going to do a reflection over that. So if you remember when we do that reflection, we technically have a rule for a reflection, but it just means that it's the same, or we don't have an exact rule for x equals 1, but it's the same distance on the other side. So if we look at our first one, so we're going to do this in green this time. My H is 1 unit from the line, so this is going to be, and this is being labeled as H double prime. Then our A is 1, 2, 3, 4, 5 units, so we're going to go on the other side 1, 2, 3, 4, 5 units, so that's going to be A double prime. Then my T is 1, 2, 3, 4, 5, 6, 7, 8 units. So we're going to go on the opposite side. 1, 2, 3, 4, 5, 6, 7, 8 units. And that's going to be my T double prime. And again, there is my new triangle. So we've done a rotation. Now we've done a reflection over the line y equals x. Okay, and the points that we get for that. For the H, we got 0 and 2. Then for the A, we got -4 and 7. And then for the T, we got -7 and 5. Okay, so we've done the rotation, we've done the reflection, and now we want to translate it. So they want us to translate it 3 units to the right and 4 units down. Now, technically, we could write a rule for this, and we could say, okay, this is going to be x plus 3 and then y minus 4. We could absolutely figure that out for the first two, or for the last thing. So if I have 0 plus 3, that's going to be 3. 2 minus 4, that's going to be -2. Okay, so again, this will be 0 plus 3. This will be 2 minus 4, which would be -2. So for this one, for A, because that's turning into U, we're going to do -4 plus 3. And then we're going to do 7 minus 4. Okay. So that's going to turn into -1, -3, and +3, excuse me. And then for the last one, I have -7 plus 3 and 5 minus 1. So that's going to be -4 and 1. Okay, so again, if I were to move these values, so I could see if I go to, so that's B, then I'm going to go to -1 and +3. So that's going to be my U. And then I have -4 and +1. That's going to be my G. So if I connect all of these, I can see that I have basically, if I go from the T to the U, I've gone down 4, so down 4 and right 3. So you can do a combination of transformations. You just need to be careful and do them a little bit at the time. So keep that in mind. If you have any questions about these, just let me know, and I'll be more than happy to help.